Dear students, welcome back. Today we will discuss ionic equations. This is a very important topic. It needs a lot of practice. So please be careful. First, try to understand how ionic equations are made. What are the rules which are kept in mind during making a chemical, ionic equation? In any equation, especially utilization, displacement reaction, formation of precipitates, I mean test for ions. During test for ions, we have precipitates for those at the same time insoluble salts. Their precipitates are formed. So these are the topics from which ionic equations are usually off. So basically, in ionic equations, first we need to know what is the concept. Basically, ionic equations are basically they represent what? They represent the dissociation of soluble ionic compounds into their ions in aqueous solution. Whenever we make an ionic equation, first of all, we have to keep in mind some important rules. Let's start ionic equations. So in ionic equations, we have to keep in mind few rules. The first, only aqueous solutions are converted into ions. Only aqueous solutions, not solid, liquid, only aqueous. The compounds, when dissolved in water, that becomes aqueous. Only aqueous solutions are converted into ions. Solid, liquids, and gases are not converted into ions. Into ions. Why we don't convert solid, liquid, and gases into ions? The reason is these are insoluble in water. That is why they don't release ions in them, right? So those solids which are soluble, definitely they will be called as aqueous solutions. But I'm talking about solid which don't dissolve, liquid which don't dissolve, similarly gases which don't dissolve, okay? We will not split them into ions. We will leave them broken. So this that means from this the point comes in our mind that solid, liquid, or gases they must be the part of ionic equations at the end. Okay, so third rule we need to keep in mind ions with similar charge on reactant side, reactant side and product side, reactant side and product side are cancelled out. We remove them. Why we remove them? Because they have nothing to do with a chemical change, with a chemical reaction, and products are cancelled out, and these ions are known as spectator ions. Those ions whose charge does not change, which do not undergo oxidation, mean loss of electron or gain of electron. So mean they have nothing to do with the change in the chemical reactions. That's why they are usually removed from the ionic equation at the end. After applying first, second, third rule, we will make the chemically ionic equation. Ionic equation will be is ready now. Let's take an example, right? For example, when a metal like zinc react with H2SO4, it produces zinc sulfate. Along with it, hydrogen gas is produced. Hope you know why this. What type of reaction is this? Just think. This is a displacement reaction. Metal which is more reactive than hydrogen in the reactivity series only react with acid. Otherwise, a metal which is less reactive than hydrogen, mean below hydrogen in the reactivity series, won't react with it. There are some exceptions. For example, copper do react with H2SO4, but in that case, it should be concentrated, not dilute. I am talking about in general dilute acid. Okay, boys, for in making ionic equations, you must be clear with the states. You know, zinc is a metal; it should be solid. Uric acid is a is aqueous. Zinc sulfate is soluble salt. It is aqueous. Hydrogen is a gas. So, either rule number one. Only aqueous solutions are converted into ions. So ions will only be made for aqueous solutions. Always keep in mind uh, the two in subscript with hydrogen will not stay here because it's positive mean it has no electron. When it has no electron, how it can be diionic? So that's why this two will go behind. So it is dibasic acid because it has two replaceable hydrogen ions in it. H2SO4, HNO3 has one hydrogen ion in it. Please be careful. Similarly, H3PO4, 3 will come behind it. Okay, so these two ions are aqueous. Similarly, this salt is also aqueous. Mean whenever we say aqueous, that means the compound is not in this form. Its ions have been made. The ions are free to move in that solution. That is why we just write in a separate state. Hope you are good in the oxidation states of these ions. Please be careful. Sulfates, nitrates, phosphates. These are few important ions. We also call them as radicals. Uh, they they usually come again and again in chemical equations. That's why we must know their charges. So in some lecture, inshallah, maybe in the coming one, I will be telling you how to memorize, how to keep these charges of the ions in mind. Yes, of course, periodic table is there, but still not everything is available in the periodic table. Like there is nothing like nitrate ion in the periodic table, sulfate, phosphate, hydroxide. Inshallah, we will do in the coming classes. Uh, H2, it is a gas, we will write it as such. Now you can write this symbols means state symbols. And now I will ask you, really, I will not listen to your answer, but you try to answer that by yourself. Which ions should be cancelled out? Definitely, you will not say about hydrogen ion because here charge of hydrogen is positive. Here it has no charge because it is free element. Free element is that element which is not combined with any other element. Hope you understand. So this sulfate has -2, this sulfate is -2. That means we can cancel sulfate on both sides. As I told you, ions with similar charge on reactant side and product side are cancelled out, and these are known as spectator ions. Okay, what about zinc? The charge of zinc is 0 here. Don't say it's a +2 or +1. Whenever you are asked the charge on particular element, to see whether the question is about ions or atom. If it is an atom, definitely it is neutral. So zinc has no charge, hydrogen has no charge because it is a covalent molecule. So these will not be cancelled out. Zinc will stay on this side. Zinc will stay on this side as well because there is a change in oxidation state of zinc from 0 toward +2. So what is left? We will write it here. Zinc is left plus, which is solid. 2H positive is left, EQ, arrow. Zinc positive 2 is left. We have to write EQ. State symbols are very important. Then H2 is left. So boys and girls, please keep in mind, this is ionic equation. So whenever you do displacement reaction, equation will be like this, especially metal reaction with acids. We have a big chapter of metals, extraction of metals. Over there, you will see a lot of equations. One of the ionic equation usually come from that topic. Okay. Similarly, in periodic table group 7 displacement reaction, that's very important. Similarly, neutralization reaction. All these type of chemical reaction will be discussed in coming classes, inshallah. Please try to subscribe my channel so that you can get notification for every new lecture which is coming from my site. And inshallah, as long as we are talking here, right? We are also doing the past paper question. Although in particular lesson we will be only solving the past paper question. You will see the question, then marking scheme I will share with you people. So better this is one example of ionic equation. You can have other examples as well. One I am giving you as a homework. Please do that as well, and you can share with me in the comment box. So this is HCl when it react with sodium hydroxide. This is a very easy equation, right? I'm sure you will be able to do this. When hydrochloric acid react with sodium hydroxide, it produces soluble salt, that is sodium chloride. We have discussed this as well in salts and properties of acids. NaCl and water will be produced. So one more, please. Cl2 plus Ki. This, I always ask this question, whether this reaction will take place or not. This will take place because chlorine is more reactive than iodide or iodine in its group. Will displace iodide ion in the form of iodine solid. And whenever these halogens are formed, we are unable to decide which state is there, but at the end, the final state will be solid for iodine. This will be aqueous. KCl soluble salt, Ki is soluble salt. All the group 1 metal and group 7 salts are soluble without any hesitation, right? Aqueous. Similarly, chlorine is a gas, bromine is a liquid, iodine is a solid, astatine is solid, and the last, yes, that's it. Thank you very much. Hope you understand. Inshallah, we will continue 2, 3 lessons on this. Take care of yourself and don't waste your time. Thank you very much.